equals tan. So we'd say tan theta equals opposite over adjacent. Then we'd substitute. So substitute gives us tan 42
Over x?
Equals opposite. So 14 over x, isn't it? So what's the difference between this one and the one we've just done?
And the x is on the bottom.
Yeah, the x is at the bottom rather than at the top. So because the x is in a different position, the algebra we need to do to rearrange is different. That's what I was saying before. So that step 3 is the only one that really ever changes. Because it's opposite over adjacent, so that the unknown is actually the bottom part of the ratio, not the top part. So it's just that when we, so that's why it's important to label it accurately and fill this in accurately. You can't just put, bits have to go in the right spot. So the angle has to go here, opposite there and adjacent there. You can't just swap those around through convenience. Otherwise, your angles are going to be all like you're not going to necessarily get the right length for it. So what's the process, do we think, for rearranging this when the unknown's at the bottom? Anyone reckon they could share with us what we might do instead of multiplying both sides by, in this case by 50? What might we do instead? What might we do now to rearrange this for x? Go on, Mitch, yeah. Divide by. We could divide by, the easiest way to think of it actually is just think we're going to divide both sides by tan 42 and then multiply both sides by x. So essentially we're actually just swapping those two things around. So the next step can be x equals 14 on tan 42. So we do divide. So then the easiest way to think of it is rather than multiplying, when it's at the bottom we just divide instead. So you are right. So what's 14 on tan 42?
That's what I was going to figure out. Oh.
So all we're doing is just swapping these around, that's all it is.
Do I have to work that out?
Yeah, just do 14 divided by tan 42 on the calculator.
And 14 divided, yeah.
What's that?
15.54.
15.54 metres. So that length would have to be 15.54 metres for that triangle to fit. Okay, and there's also, and this we're going to spend a lot of time doing this topic as well. There's a lot of sort of practical problems this can solve. This is just an example of one. Sorry for using your guys' names. But imagine we have Julia, say at the bottom of a cliff, looking up at Olivia, who's at the top of a cliff. She's looking up at an angle of 35 degrees, and she knows she's standing 20 metres away from the base of the cliff, and how high therefore is the cliff. So imagine we had here, there's a cliff here, we have Julia up the top here, sorry, Olivia up the top here, Julia is here. If she's looking up, that would be at that angle like that, wouldn't it? Are you happy with that? She's looking up, and you can see here again it's making a it'll be making a triangle here. So that what would that angle there be? 35. So she's looking up at an angle of 35 degrees. This length would represent the length of sorry, that's not funny. How high is the cliff? It's this length here, isn't it? So this length here represents the height of the cliff. What do we know? What's the other bit of information that we do know about that?
20 meters.
Yeah, we know that this length here is 20 metres, don't we? So if we know that's 20 metres, we know that's x. So these kind of problems, and we can think of, there's a lot of different applications of this. Like this can be used, for example, to find out the height of trees. Have you guys ever seen those? I think there's one in this room actually. Those inclinometer things. So you can look at. I'll find it in a second, but you can find. We got this thing where you can actually find the angles of elevation of things and stuff. So you can find heights of things without actually measure them. So here we do the same process. We label it. What's this length? It's the opposite and the adjacent. So we'd say, okay, to solve this we'd say tan of 35 equals x over 20, opposite over adjacent. Then we'd say x equals 20 times tan 35, which gives us a result of what? Yes, please, Sigrid. 14 jumping in. Lucky 14 point what, sorry?
Just 14.
Okay. So 14. So the cliff is 14 metres. So again, make sure you include those units. Yeah, and so it can be used, and so a lot of what we're going to look at, particularly later in this topic, is looking at a lot of different types of applications. But that's just an example of one. Can we turn it off, please, Lockie?